Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about engineering tribology subject. So in this, the main parameters are friction and wear and lubrication and corrosion. So now in this, in previous sessions, already we have learned what is the importance of corrosion and what are the effects of corrosion in this in the engineering tribology subject. So in continuation of this corrosion part, testing and prevention of corrosion is very important. You should know so how to test the corrosion and at the same time how to prevent the corrosion. So how many methods are there and how to apply and what is the prevention methods are there. We should learn in this topic, the corrosion topic. So that today I want to share some testing and prevention of corrosion methods we will discuss. The topics are testing of corrosion and then prevention of corrosion. The testing for corrosion. So, typically the involves various methods to assess the extent and nature of corrosion on a material or structure. But here some common techniques are given in this slide and I will explain one by one. The most important thing is, first one is visual inspection. So the simple visual examination can often reveal signs of corrosion such as discoloration, rust, pitting and cracking on the surface of the material. So the visual inspection means by seeing the object, by seeing the surface. So you can say, so this surface is rusted. So some material lost due to the corrosion. Some cracks are there. So by seeing the surface, you can say this type of inspection is called the visual inspection. So the rust and the fitting or cracking signs you can observe on the surface of the material, so that you can easily inspect the corrosion symptoms of this the surface. So second one is the weight loss method. In the weight loss method, this involves measuring the weight loss of the material due to the corrosion over a specified period of exposure to a corrosive environment. So suppose if any object is exposed to environment conditions, atmosphere conditions, then automatically some rust will be happen and then at the same time after some duration the loss of material also will be present. So you can test the object by measuring the weight. So how much weight before rust and after rust, what is the weight of the method? If there is any weight loss observed, so the compulsory that you can say that that object, the surface is corroded. So this type of method is weight loss method. So that whenever the object is the present specified period of a time in environment conditions, compulsory there is a loss of material. So next one is electrochemical techniques. So in electrochemical methods such as polarization resistance, electrochemical impedance and spectroscopy and potentiodynamic polarization are used to evaluate corrosion rates and corrosion mechanisms. So already we have studied in previous sessions corrosion mechanisms, and at the same time the corrosion rate you can evaluate. So maybe using these electrochemical techniques. So these techniques are such as polarization resistance and electrochemical impedance and spectroscopy and potentiodynamic polarization methods are there. By using these techniques, you can evaluate the corrosion. Okay. So these all these methods comes under testing methods. Next, salt spray test. This test exposes the material to a highly corrosive salt spray environment to accelerate corrosion and assess the material's resistance to corrosion. To accelerate corrosion and then same time assess the material's resistance to corrosion. So by using this salt spray, you can calculate the corrosion rate. Clear. And then immersion test. In this test, the material is immersed in a corrosive solution for a specified period, and the extent of corrosion is evaluated by measuring parameters such as weight loss, metal loss, or corrosion rate. Immersion test. Suppose which one you are going to be tested. So that component you have to immerse in a corrosive solution some particular specified period, and then evaluate after some time after completion of the duration. So by measuring the parameters like weight loss, how much weight lost, and then what is the metal loss, and then what is the corrosion rate. So these are the parameters. By measuring these parameters, you can test. So this type of test is immersion test. Next, electron microscopy. So this is to identify corrosion products and mechanism techniques such as scanning electron microscopy. So that is you can say SEM, scanning electron microscopy, or transmission electron microscopy, that is TEM, can be used to examine the surface morphology and microstructure of the material. So microstructure and then the surface of the morphology, by using this microscopic test, you can say, so you can identify the corrosion. So unless you can't. So that's why these the scanning under this electron microscopy or the transmission electron microscopy TEM. Clear. So this type of test is called as electron microscopy. Next one is X-ray diffraction, XRD. So XRD can be employed to analyze the crystalline structure of corrosion products formed on the material surface, providing insight into the corrosion process. So the XRD, the X-ray diffraction, can be employed to analyze the crystalline structure. So different crystalline structures are available for the corrosion of the products. So what is the crystalline structure of the corrosion product? You have to analyze. Clear. The formed on the material surface. So providing insight into the corrosion process. Next one is X-ray photoelectron spectroscopy, that is XPS. So XPS is a surface sensitive technique that can identify the elemental composition and then chemical state of the corrosion products. One is the identify the elemental composition, chemical state of the corrosion products, and aiding in understanding the corrosion mechanism. So these are the X-ray photoelectronic spectroscopy test. So this is very sensitive technique. And an acoustic emission testing. So this technique monitors the acoustic emissions generated by corrosion process, such as cracking or localized corrosion, to assess the severity of corrosion damage. But by using this acoustic method, so acoustic emission testing, here you can calculate the cracking and localized corrosion. So some acoustic emissions generated by the corrosion process. So suppose if any object is corroded, that corrosion generated some acoustic emissions. By monitoring these acoustic emissions, you can calculate this corrosion rate. To assess the severity of the corrosion damage, you can identify and then you can prevent the corrosion. So so that you can reduce the corrosion, and you can reduce the cost of the product. You can eliminate also. Next, testing for corrosion, ultrasonic testing. So the ultrasonic techniques can be used to detect corrosion, measure its depth, and assess its extent by analyzing changes in ultrasonic wave propagation through the material. So whenever the ultrasonic waves are passes through the corroded material or surface of the tested to be tested part, so the wave propagation, we analyze the changes. What are the changes in the wave propagation? By analyzing these changes, you can calculate the corrosion rate. You can detect by using this technique. So measure its depth and extent by analyzing changes in ultrasonic wave propagation through the material. So the choice of testing method depends on factors such as the type of material, and then expected corrosion mechanisms, and the environment in which the material is used, and the desired level of detail in the assessment. So the choice of testing method depends upon this all these factors, that is type of material and the expected corrosion mechanisms. So these are the important testing methods: ultrasonic testing, and acoustic emission testing, and X-ray protoelectron spectroscopy, and electromicroscopy, and X-ray diffraction method. Another techniques are immersion test, salt spray test, and electrochemical techniques, visual inspection, and weight loss method. These two are very very simple tests, and then you can test by seeing the object and by measuring the weight loss. These electrochemical and techniques, you have to use some the polarization methods. Similarly, the salt spray test also you have to use some so salt spray environment to accelerate the corrosion. And immersion test also you have to use some corrosion solution, and then the test material is immersed in a corrosive solution for a specified period, and then by evaluating by measuring parameters as a weight loss and metal loss, the corrosion rate you can calculate. Similarly, electron microscopy. So these two methods are there: SEM, scanning electron microscopy, and transmission electron microscopy (TEM). X-ray diffraction, analyze the crystalline structure of corroded products, clear by providing insight into the corrosion process. Similarly, X-ray photo electron spectroscopy, and so by using these techniques, you can calculate and you can understand the corrosion mechanism. Acoustic emission testing, these techniques monitors the acoustic emissions generated by corrosion process, such as cracking or localized corrosion, to assess the severity of corrosion damage. You can identify by using these acoustic emission testing. Similarly, in the ultrasonic testing, by passing the by generating this corrosion ultrasonic wave propagation, so you can analyze and then measure its depth, and they analyze its extent of ultrasonic waves. So by using this analysis, you can say the corrosion rate. So that all these methods depends upon the type of material, and what are the expected corrosion mechanisms, and then environmental conditions. The second part is prevention of corrosion. So how to prevent? The prevention of corrosion is crucial aspect of maintaining the integrity and longevity of various structures, equipment, and materials. Here are some methods of prevention of corrosion. So I will show you. So prevention of corrosion is a main important aspect of maintaining the integrity and longevity of various structures. So if you can't prevent, if you not prevented the corrosion material, so then ultimately the failure will be happened and the loss of material also will be there. So here are some methods to given to how to prevent the corrosion before failure. So one is, the important thing is material selection. So the choosing the right material for a particular application can significantly reduce the risk of corrosion. So that's why you should know the properties, the material properties uh, before designing any component. So if you don't know the properties of material, so the failure will be happen. So the 100% of the component will be fail. So you can reduce the risk of corrosion by using this material selection method. So right material for select for right application. For example, using stainless steel or titanium instead of carbon steel can reduce the likelihood of corrosion. Clear? So here example given. So similarly, uh, right material you select for right application. So otherwise it will be fail and due to the corrosion and fatigue properties. Clear? So design of structures. Designing structures with corrosion in mind can also help prevent corrosion. For example, using a drainage system to remove moisture and debris can reduce the risk of corrosion. In drainage system, remove the moisture and debris can reduce the risk of corrosion. So otherwise it will be corroded. The designing structures with corrosion in mind can also help prevent corrosion. And alteration of materials. In this, the altering the chemical composition of materials can also help prevent corrosion. So you can change the chemical composition of the particular material by adding some materials. For example, adding corrosion resistant coatings or treatments to metal surfaces can reduce the risk of corrosion. So alteration by using the change of metal composition, uh, it can reduce the risk of corrosion. Next, alteration of environment. So altering the environment in which a material is used can also help prevent corrosion. For example, using a dry and this clean environment can reduce the risk of corrosion. So dry condition and dry environment and clean environment reduce the risk of corrosion, but not in a wet environment. Suppose in a wet environment, the risk of corrosion chances are very high. So that altering the environment in which a material is used can also help prevent corrosion. So based on depends upon the environmental conditions, how to use. So then only you can reduce the corrosion. Cathodic protection. So cathodic protection involves applying an electric current to a metal surface to prevent corrosion. This can be done by attaching an anode to the metal surface and connecting to a power source. So this method is called as cathodic protection. It involves applying an electric current to a metal surface. So the metal surface, which part you are going to be prevent. So the component, the component is protected by metal surface, protected by the applying an electric current. This can be done by attaching an anode to the metal surface and then connecting it to a power source. Next, anodic protection. Anodic protection involves applying an electric current to a metal surface to prevent corrosion. So, anodic protection involves applying an electric current to a metal surface. So, in the previous case, cathode protection is there. So, that is involves applying an electric current to metal surface to prevent corrosion. This can be done by attaching a cathode to the metal surface. In this case, in anodic protection, the cathode attaching to the metal surface and connecting it to the power surface. But in cathodic protection, the anode to the metal surface is connected and connecting it to a power source. These are the differences between this cathodic protection and anodic protection. Next is coatings. So applying a coating to a metal surface can also help prevent corrosion. So by applying the coatings, the paint and the varnish, so like this zinc coating, so like this you can reduce the material. You can reduce the material corrosion and then improve the material life. So including paints, varnishes, and plastics. Next, corrosion inhibitors. The corrosion inhibitors are chemical substances that are added to a material to prevent corrosion. These substances can be applied to the material before or after its manufacture. These substances can be applied to the material before manufacturing or after manufacturing. You can add these corrosion inhibitors. So corrosion inhibitors are mainly chemical substances, so that are added to the material, which material to be prevent from the corrosion. Next one is corrosion resistance alloy. Using corrosion resistance alloys can also prevent corrosion. These alloys are made from a combination of metals and resistance to corrosion. So using a corrosion resistance alloys can also prevent the corrosion resistance alloys. So these alloys are made from the combination of metals. So two, three metals combination will give the resistance alloy. So the super resistance alloy will give resistance to the corrosion. Next, regular maintenance. This one also one prevention method. So regular maintenance is also important for preventing the corrosion. This can include cleaning, inspecting, and then material regularity, and replacing any damaged or corroded parts. So this can include only cleaning and inspecting the material regularity. So regularly you have to check, you have to replace or and damaged part you can replace or corrected parts. So these are the regular maintenance. Also the preventing of corrosion. Next, monitoring the material for signs of corrosion. This is also important. It's monitoring the material. The sign is very important. This can include monitoring of sign of rust, corrosion, other forms of damage like cracks. Clear. So it indicates the part to be corrosion and corroded. So that the monitoring of the material for signs of corrosion, you can by monitoring the material you can reduce. Next, these are the some of the methods to prevention of corrosion. By using these methods, it is possible to reduce the risk of corrosion and extend the lifespan of the various structures, equipment, and materials. So not only reduce the risk of the corrosion, so it can extend the lifespan of the various structures, equipment, and materials. Clear. So that you have to first identify the corrosion, definition, and then testing, and then prevention methods. These are the preventing methods. So the methods are here: material selection, design of structures, alteration of materials, and alteration of environment, cathodic protection, anodic protection, coatings, and then corrosion inhibitors. So coatings topics already you have studied in the previous sessions. The separate topic is there, coatings. So many coating methods are there, and then applications of coatings you have seen. Next, corrosion inhibitors are also we have studied. So these are chemical substances, and corrosion resistance alloys. We have to create the resistance alloy by combination of two three materials. It gives alloy material. So the materials they are resistant to corrosion. Regular maintenance also very important method to prevent the corrosion. Monitoring of the material and sign of corrosion also very important. This can include monitoring for signs of rust, corrosion, other forms of damage. So that these all these methods comes under the prevention of corrosion. By using these methods, the possible to reduce the risk of the corrosion. So you can't eliminate the total entire 100% risk, but somewhat you can reduce the risk, and you can improve the material properties, and you can extend the lifespan of various structures, equipment, and materials. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.